Beneath a winter sky, where the air grows silent and the world turns white, one of nature's most delicate wonders begins to form. A snowflake is never just frozen water. It is a record of motion, temperature, and time. A tiny crystal shaped by the atmosphere as it falls through layers of cloud and cold. At the heart of every snowflake lies a simple rule of physics. Water molecules, as they freeze, arrange themselves into a structure with six-sided symmetry. That hexagonal foundation is the hidden starting point for the astonishing patterns we see in the snow. From there, the journey becomes beautifully unpredictable. As the crystal grows, it passes through changing conditions in the sky. A slight shift in humidity, a drop in temperature, a change in air movement. Each one affects how the crystal branches, feathers, and expands. That is why snowflakes can look so intricate, so ornate, and so seemingly impossible. Their beauty comes not from perfect repetition, but from variation within order. This is where snowflakes begin to resemble fractals, not perfect mathematical fractals, but natural forms that echo themselves at different scales. A branch splits into smaller branches, and those branches split again, creating a visual rhythm that feels almost endless. The result is a pattern that seems designed, even though it is built by simple physical laws. Mathematicians often point to the Koch snowflake as a way to understand this kind of repeating complexity. It is a mathematical shape, not a real snow crystal, but it shows how elegant detail can emerge from a simple rule repeated over and over. In that sense, it gives us a language for seeing the beauty in snow. But real snowflakes are even more remarkable than the model. Why? Because no two snowflakes are expected to travel exactly the same path. Each one is shaped by its own sequence of atmospheric conditions, making exact duplication extraordinarily unlikely. A snowflake is not manufactured. It is negotiated between water vapor, temperature, and the changing sky. That is why each flake feels so personal, so fleeting, so alive in its brief moment of existence. Hold one in your hand, and you are not holding a simple crystal. You are holding a story of physics in motion, a pattern carved by the invisible architecture of the atmosphere, a frozen expression of symmetry, chance, and transformation. And then, almost instantly, it vanishes. That is the paradox of the snowflake. It is both precise and temporary, both orderly and wild. A tiny frozen star that appears for only a moment, yet carries within it the quiet genius of nature's design.